In the today's class, we are going to discuss about FIR lattice structures, finite impulse response lattice structures. See, first we will see the transfer function of an FIR filter, that is written as it is the ratio of what output by input y of z by x of z, that is equal to 1 plus summation over the limits I equal to 1 to m am of I z to the power minus I. So I will represent it as a equation number 1. Now here m is the this m indicates order of the FIR filter. This m indicates order of the FIR filter, and am of 0 equal to 1. So first find first order. Let us say first order, let us say, is calculated as we know, where m stands for order of the filter. First order means I am going to substitute m equal to 1. Then equation 1 becomes, if I substitute m equal to 1, then equation 1 becomes this m equal to 1, as well as wherever m is there, there substitute 1. Then equation 1 becomes y of z by x of z, h of z equal to 1 plus summation over the limits I equal to 1 to m is there. M equal to what? We taken 1. Hence, a m of I is there. Here m equal to 1, a1 of I multiplied by z to the power minus I. Further simplification, y of z by x of z equal to 1 as it is, plus I stands for 1. So substitute here I equal to 1, a1 of 1 multiplied by z to the power minus 1. Then let's do the cross multiplication of this thing. Nothing but take x of z towards right side. Then it becomes y of z equal to x of z plus a1 of 1 z to the power minus 1 multiplied by x of z. So let us take the inverse z transform for this one. Then we got y of n equal to x of n, inverse zt of x of z is x of n, plus as it is a1 of 1 coefficient term as it is. The inverse zt of this one is x z raised to minus 1 multiplied by x of z. So inverse z is one time delay is there, that is a1 of 1 into x of n minus 1. So this is about uh, taking the inverse jet transform for the equation. Then we got next, see here, sketch the lattice structure for first order difference equation. We got first order difference equation. So for that I'm going to sketch x of n is what? Input sequence. X of n is what? Input sequence, that is applied f naught of n, r naught of n, one time delay, r naught of n minus 1, and coefficient terms are represented as k1 k1 here, and f1 of n, that is equal to y of n. Here this indicates upper channel, where f1 of n, that is equal to y of n, that is known as upper channel output. R1 of n is known as the lower channel output. So this diagram shows the structure of first order. Let us say the inputs are what? In this case, x of n is the input, that is given as a upper channel input as f naught of n, and for the lower channel it is given as a r naught of n. So we are going to represent inputs are as f naught of n and r naught of n. This is equal to what? X of n. Okay, f naught of n equal to r naught of n equal to x of n. These are the inputs. What about outputs? Outputs are two outputs we are getting, that is upper channel output is f1 of n, that is y of n, and lower channel output is r1 of n. So outputs we are going to represent f1 of n. So what will be the f1 of n? How to calculate f1 of n? In order to get f1 of n, see, it is the addition of what? It is the addition of what? F naught of n. F naught of n is added with f naught of n is added with k1 multiplied by, here r naught of n is divided by one time, so here we are getting r naught of n minus 1. Hence f naught of 1, f1 of n, we are getting f naught of n is added with k1 multiplied by r naught of n minus 1. So same thing I'm writing here. Output, upper channel output is written as f1 of n, that is equal to f naught of n plus k1 multiplied by r naught of n minus 1. I'm going to represent this as equation number 3. Similarly, write the equation with the help of first order diagram, structure of first order, let us say, write the equation for lower channel output. What is the lower channel output? Lower channel output is R1 of n. So R1 of n is the what? It is the addition of what? K1 multiplied by F0 of n is add with R0 of n minus 1. So I'm going to write equation for lower channel output as R1 of n. R1 of n is equal to K1 multiplied by F0 of n plus R0 n minus 1. Let us represent it as equation number 4. So from equation 2 and 3, we find that K1 equal to A1 1. So you can compare equation 2 and 3. From the comparison, we can say that K1 equal to A1 of 1. So then F1 of n equal to y of n. It is from the diagram we are writing F1 of n equal to y of n. So let us go for second order structure. Second order structure means we have to take order of the filter as m equal to 2. Now we are calculating second order lattice structure. So in order to calculate second order lattice structure, let us take order of the filter as m equal to 2. If you substitute m equal to 2 in the equation, that is ratio of y of z by x of z, that is equal to 1 plus summation over the limits I equal to 1 to 2, because order of the filter we taken as a 2. Reason for that is we are calculating second order, let us say a2 of I z to the power minus I. So expand the summation term, 1 plus first I equal to 1, substitute a2 of 1 z to the power minus 1 plus substitute I equal to 2, a2 of 2 z to the power minus 2. So similarly do the cross multiplication, then take x of z towards RHS side, 1 into x of z, this multiplied by x of z to the power minus 1 x of z plus a2 of 2 z to the power minus 2 x of z. So we got. Similarly take the inverse z transform, y of n x of n plus a2 of 1 x of n minus 1 plus a2 of 2 x of n minus 2. Let us represent as a equation number 5. Now let us assume y of n equal to f1 of n plus k2 into r1 of n minus 1. I'm going to represent another next equation, that is equation number 6. Already we calculated equation in from equation 3 and equation 4. We are going to substitute these two equations in equation 6. What is equation 3? That is f1 of n. And what is equation 4? r1 of n. So those equations I am going to substitute in equation number 6. F1 of n is, you can refer, F1 of n is F0 n plus K1 into R0 of n minus 1. So here F1 of n equal to, I am going to substitute F0 of n plus K1 into R0 of n minus 1 plus K2 as it is, We have equation for R1 of n, lower channel output. We have the equation for lower channel output. If you want to calculate, see here I am writing R1 of n equal to K1 F0 of n plus R0 of n minus 1. If I am going to delay by one time, it becomes R1 n minus 1. So the corresponding delays K1 coefficient term as it is F0 of n minus 1 plus R0 of n minus 2, because we delayed one time. Same equation we are getting here. Here I am writing K2 as it is, R1 of n minus 1. One time delay, it becomes K1 F0 of n minus 1 plus R0 n minus 2. So rearrange the terms, because here R0 of n minus 1 is there. Here also R0 of n minus 2 is there. Arrange in a sequential manner. So y of n equal to f0 of n as it is, plus k1 r naught of n minus 1, then multiply k1 into k2, that is k1 k2 f naught of n minus 1, then k2 multiplied by r naught of n minus 2. Okay, this is about equation 7. So from this equation we are going to calculate, since we know what is the value of f naught and r naught are the inputs, f naught and r naught are the inputs, so f naught r naught is equal to what, x of n. In the equation, wherever f naught, wherever r naught is there, let us substitute as a x of n. From the equation number 7, I'm going to rewrite as y of n equal to x of n plus k1 r naught of n minus 1 is there, that is replaced by x of n minus 1 plus k1 k2 f naught of n minus 1 is there, that is replaced by x of n minus 1 plus k2 r naught of n minus 2 is there, that is replaced by x of n minus 2. It means I expressed all the terms in terms of x of n. Now for the simplification, see here x of n minus 1 is there, here also x of n minus 1 is there. Let us take the coefficients of x of n minus 1 separately. It is y of n as it is, x of n, x of n minus 1 I'm going to take the common. Here left with what, k1 plus here left with what, k1 k2. Hence k1 plus k1 k2 multiplied by x of n minus 1 plus is it this equation as it is, k2 into x of n minus 2. Let us represent as a equation number 8. Compare equation 5 and equation 8. What is equation 5? Equation 5 we got, here I'm going to write equation 5, that is y of n equal to x of n plus a2 of 1 x of n minus 1 plus a2 of 2 x of n minus 2. So this is what, this is equation 5. Now to the comparison of equation 5 with equation 8, what we are getting to the comparison, compare these two equations. X of n as it is, x of n minus 1 is there, and the coefficient of x of n minus 1 is a2 of 1 is there. Here k1 plus k1 into k2 is there. Similarly x of n minus 2 is there, here also x of n minus 2 is there. Coefficient of x of n minus 2, k2 is there, here a2 of 2. By comparing these two equations, we are going to write as a2 of 1 equal to k1 plus k1 k2 and a2 of 2 equal to k2. So if you take common here, we can write, taking common k1 common, that is 1 plus k2, correct, 1 plus k2. So we got a2 of 1 equal to k1 into 1 plus k2, a2 of 2 equal to k2. Next, what about k2? K2 is a2 of 2. Hence we can write a2 of 1 equal to k1 multiplied by 1 plus k2 means a2 of 2. So we calculated. So from this equation we are going to write, from this equation k1 equal to coefficients, because in lattice structure we sketched k1 k2 coefficients terms, correct? So we have to calculate those values. K1 equal to what, a2 of 1 divided by 1 plus a2 of 2. Similarly k2 equal to, we calculated, that is a2 of 2. Coefficient k1 and k2 are calculated. Those values we have to substitute in the final second order structure. X of n is the input, okay, that is applied f naught in the upper channel, f naught of n, r naught of n, first coefficient terms, first order, let us say k1, and we got first order output as a upper channel as a f1 of n, lower channel as a r1 of n. Then we made second time delay in the second order lattice structure, z to the power minus 1. We got here r1 of n minus 1, here we got r0 of n minus 1, and second order coefficient terms k2, and finally in the second order lattice structure output is y of n. That output is represented as F2 of n, it is the upper channel output. R2 of n, it is a lower channel output. If it goes on doing like this, in general, in similar manner, mth order lattice structure can be implemented as it is what? It is first stage, first case, nothing but first order lattice structure means stage 1, second order means stage 2. It goes on like this. We have to cascade connection, then we'll get mth order lattice structure. So in next, we are going to discuss how to conversion from lattice structure to direct form and vice versa, direct form to lattice structure. For that, we have to follow some formulas. Formulae for converting direct form to lattice structure. In the examination, you may give direct form. With the help of direct form, we have to calculate, we have to sketch the lattice structure. Sometimes we will give the lattice structures, or sometimes we will give the coefficients of lattice structures. We have to sketch direct form. So first we'll see how to convert from direct form realization to lattice structures. So in the examination, he may give the direct form relation diagram, or he may give the coefficients of the functions. See here. This is the procedure for converting direct form to lattice structure. For here, M indicates what? M stands for order of the filter. It varies from M, M minus 1, M minus 2, M minus 3, up to where? Up to it is 1. The order of the filter is from capital M to 1. And the coefficients. K stands for coefficients of lattice structures. Already we discussed in the first order we represented K1, in the second order we represented K2, in third order K3, K4, K5, so on. In general, we are writing Km equal to M of M. It is a general representation of coefficient of lattice structures. So then it is a formula for calculating the coefficients, that is Am minus 1 of I, that is equal to Am of I minus Am of M multiplied by Am of M minus I, where the value of I stands for 1 to M minus 1, divided by 1 minus K square M. See, using these two formulas, we will discuss one case, that is order of the filter is 2. If it is a second order filter, then how to calculate these coefficient terms? We know as per the formula, if M value varies from where to where, M minus 1, M minus 2 up to 1. In this case, we taken one case if M equal to 2. So it varies from where to where, up to 1 it has to vary. So if M equal to 2 is given, then 2, then 1, M equal to 1, we have to calculate. So as for this formula, what is M? First we'll go for M equal to, if M equal to 2, it becomes K2 is equal to A2 of 2. K2 is equal to A2 of 2. Fine. Next, if M equal to 1, what happens? K1 that is equal to A1 of 1. K1 that is equal to A1 of 1. Okay. Next. So for M equal to 2 and I equal to 1, because the value of I varies from 1 to M minus 1. 1 to M minus 1 means 1 to here M value is 2. 2 minus 1 means I value stands only for 1. For M equal to 2 and I equal to 1, then equation 2 becomes, this equation becomes M equal to what? 2. 2 minus 1, it is 1. A1. I value is what? I value is 1. A1 of 1 equal to M value is 2. 2, yeah, I value is 1. A2 of 1 minus M2, here also 2, A2 of 2 multiplied by A2, M is 2, A2 of 2 minus 1, that is A2 of 1 divided by 1 minus K square M. M is what? 2. K2 square. Okay, here from this equation, further simplification, A2 of 1 I am going to take the common. So if I take A2 of 1 common, left with 1 minus A2 of 2 divided by 1 minus K2 square. Next, further simplification, K2 equal to what? Already we calculated. K2 equal to A2 of 2. Substitute here. 1 minus A2 of 2 square. So for the simplification, here inside the bracket in the numerator, 1 minus A2 of 2 is there. In the denominator, 1 minus A2 2 of square is there. It is 1 minus AB. So in general, I am telling, if it is A minus B, it is A square minus B square. a minus b divided by a square minus b square. So we can write a minus b divided by a plus b into a minus b, correct? A minus b get cancelled. Similar way, it is what? Yeah, if you are simplifying this one, it is, if you take a minus b form, it becomes a square minus b square. So one term get cancels, left with a2 of 1 divided by 1 plus a2 of 2. This is what? a1 of 1. a1 of 1 equal to what? Already we calculated. a1 of 1 is k1. Hence k1 equal to what? a2 of 1 divided by 1 plus a2 of 2. So what we calculated here? Here we taken the one example as if second order case is taken, m equal to 2, we got k2 directly, then we left with what? Calculation of k1, hence we calculated coefficient k1. So from the given value of a, we calculated coefficients k1 and k2. Then those value have to sketch in the diagram. Conversion from vice versa, conversion from lattice to direct form realization. In this case, we will go for reverse. If the order of the filter starting from ascending order, m equal to 1, 2, 3, 4, or so on up to a m. In this case, in case of direct form to, let us say, he will give the values of a coefficients. We have to calculate k1, k2, k3, so on up to km. In case of conversion from lattice structure to direct form, he will give the values of k1, k2, k3, goes on km, and we have to calculate coefficients am. Okay. So for that, for m equal to 1, 2, 3, ascending order up to m, am of 0 equal to 1, am of m equal to km. Here also we discussed am of m equal to what? Km. Same thing. Am of m equal to what? Km. Then am of I equal to, this formula varies. Am of I equal to am of, sorry, a m minus 1 of I plus am of m multiplied by am minus 1 into m minus I, where the value of I varies from 1 to m minus 1. So this is the formula. With the help of this formula, we are going to discuss numericals. First example, let us take, determine the coefficients km. So where k value stands for, it is present in the lattice structure. Determine the coefficients km of the lattice filter corresponding to the FIR filter described by the system function. See in this example, and also draw the corresponding second order lattice structure. So in this example, he given the system function, or we can say transfer function. H of z equal to 1 plus 2 z to the power minus 1 plus 1 by 3 z to the power minus 2. It is the what? System function, or we can say transfer function of the FIR filter. With the help of this system function, we have to find the coefficients, the value of km. It is a second order means, of course we are going to get two coefficients k1 and k2. Second order means the order of the filter is what? 2. Yes. First, I am going to write from the given question. I am going to list the given data. Here we are. What is the given? A2 of 1. So this coefficient term, this indicates what? If you are writing like this, h of z equal to, sorry, y of z divided by x of z, correct? Then that is equal to, or in a separate paper I will discuss, h of z equal to 1 plus 2 into z to the power minus 1 plus 1 by 3 z to the power minus 2. It is the given system function. And h of z equal to what? It is the ratio of output by input. That is 1 plus 2 z to the power minus 1 plus 1 by 3 z to the power minus 2 to the cross multiplication. Hence y of z equal to x of z plus 2 into z to the power minus 1 x of z plus 1 by 3 z to the power minus 2 x of z. Let us take the inverse z transform. Take inverse Z transform. So what we're getting, y of n equal to x of n plus coefficient term 2 as it is. Inverse Z transform of this one is x of n minus 1 plus 1 by 3 x of n minus 3. Sorry, x of n minus 2. So one time delay is there, twice delay is there. So what this indicates, if you compare with the standard format, already we discussed in the standard format. See here, this one for the first order we discussed. For the first order it is x of n plus a1 of 1 x of n minus 2. For the second order what we got, for the second order we got like this, y of n equal to, for the second order, x of n plus a2 of 1 x of n minus 1 plus a2 of 2 x of n minus 2. Let's do the comparison of these two equations. Let us do the comparison of these two equations. What we get, do the comparison of these two equations. So after comparison, x of n as it is, 2 indicates what? 2 indicates a2 of 1. Hence we are going to write a2 of 1 equal to 2, and 1 by 3 indicates what? a2 of 2 equal to 1 by 3. So we got coefficients a2 of 1 and a2 of 2. So further simplification, same thing, a2 of 1 equal to what? We got a2 of 1 equal to 2 and a2 of 2 equal to 1 by 3. Okay, so let us recall the formula. For m equal to m minus 1, m minus 2 goes on up to where? So what we are discussing right now, we are discussing conversion from direct form, because system function is given. System function nothing but it is a direct form. System function nothing but if we have the values coefficients of a. So recall the formula for conversion from direct form to, let us say, for m equal to m, small m equal to capital M, m minus 1, m minus 2, m minus 3, so on up to where 1. Km equal to m of m. This is the formula. Let us substitute, because order of the filter is given, that is second order, m equal to 2. It stands for m equal to 2. If m equal to 2, we get what we get? K2 of K2 equal to A2 of 2. Right? Substitute m equal to 2. K2 equal to A2 of 2. A2 of 2 already calculated, that is 1 by 3. Hence, K2 equal to A2 of 2 equal to 1 by 3. We calculated. Okay, one value is calculated. Directly we calculated one value, that is from the given system function. We know that K2 equal to A2 of 2 equal to 1 by 3. Left with what? We have to calculate next coefficient term, that is K1. If m equal to 1, what will get? K1 equal to A1 of 1. Right? If m equal to 2 and I equal to 1, then this equation becomes m equal to 2, I equal to 1, because the value of I varies from 1 to m minus 1. 2 minus 1 means 1. M is what? 2. 2 minus 1, 1. A1 of 1 equal to A1 of 1 equal to, then m is what? 2. A2 of 1. Then already we have formulated. Directly I am going to write. No need of further one second simplification. A1 of 1 equal to what? A2 of 1 divided by 1 plus A2 of 2. A2 of 1 is, we got from the given data, that is A2 of 1 is what? 2. Okay. Hence, A2 of 1 is 2 divided by 1 plus A2 of 2. A2 of 2 is what? Already we calculated, that is given. A2 of 2 is what? 1 by 3. So 2 divided by 1 plus 1 by 3. Do the simplification, we got 3 by 2. Hence, K1 equal to what? K1 equal to A1 of 1 equal to 3 by 2. This one is we got. Next is substitute these values in the second order lattice structure. Already we discussed, this is the nature of the second order lattice structure. X of n is the input. It is a lattice structure. Second order lattice structure. Second order means 2 delays, 2 coefficients, K1 and K2. X of n, this is what? F naught of n, this is what? R naught of n, and we are getting R naught of n minus 1 here. This is what output is, F1 of n. This is R1 of n, and here we are getting R1 of n minus 1 delay. Okay, coefficients we calculated, K1 is 3 by 2, similar K1 is 3 by 2, substitute here. K2 is what? 1 by 3, K2 is what? 1 by 3, substitute. This is the what? Solution. Next, we'll move on to next problem, vice versa. If coefficients of lattice structures are given, then how to calculate, how to sketch diaphragm relations. Let's see the problem. Let the coefficients of three stage, see it is given three stage, FIR lattice structure are, three stage means we are getting three coefficients, K1 equal to 0.1, K2 equal to 0.2, K3 equal to 0.3. Find the coefficients of the direct form 1 of FIR filter and also draw its block diagram. So make use of formula, reverse conversion, nothing but conversion from lattice structure to direct form. For that formula is M equal to, in ascending order, 1, 2, 3, so on up to where? Yeah. So this is this general formulas we are making use of here. M equal to 3 because it is this three stage. It is the three stage means order of the filter is 3. M equal to 3 since there are three stages in the FIR lattice structure. With the help of these formulas, go for how to substitute. The value of M varies from this capital M is 3. Capital M is 3. It varies from 1 to up to where M means 3. So we have to substitute M equal to 1, 2, 3. So let us start with M equal to 1. For M equal to 1, this equation becomes A1 of 0 equal to 1. Next, A1 of 1 equal to Km. K means K1. K1 is given, that is 0.1. Next, if M equal to 2, A2 of 0 equal to 1. A2 of 2 equal to K2. That is also given 0.2. Next, go for next one. A2 of 1. I value stands for 1 to M minus 1 means 1. In the third equation, A2 of 1 is equal to A1 of 1 plus A1 of, A2 of 2, correct, multiplied by A1 of 1. 2 minus 1 means 1. So this is nothing but 1. And for the simplification, A2 of 1 as it is, A1 of 1 is there, that is A1 of 1 is 0.1. Then A2 of 2 is, that is 0.2, multiplied by A1 of 1. A1 of 1 is what? 0.1. So for the simplification, after simplifying this one, we are getting 0.12. Hence, A2 of 1 equal to 0.12 we got. Next, if M equal to 3, M equal to 3 means A3 of 0 equal to 1, A3 of 3 equal to K3, and same thing, A3 of 0 equal to 1, A3 of 3 equal to K3, that is given. Next, go for this one. Here I value varies from 1 to M minus 1 means 1 to M minus 1 means M value is 3. 3 minus 1 means 2. I stands for I equal to 1 and I equal to 2 in this equation. First, M equal to 3 is there. A3 of 1, A3 of 1. Next, AM minus 1 of I is there. So this becomes A2 of 1 plus AM of M is nothing but A3 of 3 multiplied by AM minus 1 of M minus I is there. It becomes A2 of 2. Substitute the corresponding values. A2 of 1 is 0.12, already we calculated here, plus A3 of 3, A3 of 3 is 0.3 here. Next, A2 of 2, A2 of 2 is also we calculated, that is given, that is 0.2. A2 of 2 is what? 0.2. Substitute and do the simplification, we will get 0.18. This is what? A3 of 1 equal to 0.18. So what we calculated? A3 of 1, A2 of 1, A1 of 1. Okay, A1 of 1, A2 of 1, A3 of 1. Okay, next. In the same equation, if I equal to 2, if I equal to, what happens? A3 of 2 equal to, A3 of 2 equal to A2 of 2 plus A3 of 3 multiplied by A2 of 1. Substitute the corresponding values. A2 of 2 is what? 0.2 plus A3 of 3 is what? 0.3 multiplied by A2 of 1 is 0.12. For the simplification, we will get 0.236. We will get 0.236. Hence, what we are doing, we are realizing diag form, converting from lattice structure to diag form. This is the equation for uh, converting from lattice to diag form. H of z equal to 1 plus summation over the limits I equal to 1 to m of I z to the power minus I. Here h of z equal to the value of m that is given. Third stage lattice structure is there. Because of that reason, m equal to 3. A3 of I multiplied by z to the power minus I. Expand the summation term. H of z equal to 1 plus A3 of 1 z to the power minus 1 plus A3 of 2 z to the power minus 2, A3 of 3 z to the power minus 3. So we are supposed to calculate A3 of 1, A3 of 2, A3 of 3. Already we calculated. A3 of 1 is what? A3 of 1 is 0.18. A3 of 1 is 1 plus 0.18 z to the power minus 1. Next, A3 of 2. A3 of 2 already we calculated. A3 of 2 is what? 0.236. 0.236 multiplied by z to the power minus 2. A3 of 3. A3 of 3 is already we calculated. In the given equation itself, it is there. A3 of 3 is K3, that is 0.3. This one we have to substitute. Then it becomes 0.3 z to the power minus 1. So this is what it is, the system function for diag form. So this equation, if you are going to simplify further, h of z equal to, we got 1 plus 0.18 z to the power minus 1 plus 0.236 z to the power minus 2 plus 0.3 z to the power minus 3. So this is nothing but it is the ratio of y of z by x of z to the cross multiplication. Hence we will get y of z is equal to 1 plus 0.18 z to the power minus 1 x of z plus 0.236 z to the power minus 2 x of z plus 0.3 z to the power minus 3 x of z. Take the inverse z transform. Y of n equal to 1 plus 0.18 as it is, x of n minus 1 plus 0.236 x of n minus 2 plus 0.3 as it is, x of n minus 3. This is the equation. Now for this equation, we have to sketch diag form realized.